Everyone. This is day one of our unit one. This is 1.02 arithmetic sequences and series. So today we're going to write equations for an arithmetic sequence, and we're also going to calculate the arithmetic series. All right, so we are being recorded. You should have your pen or pencil and paper and your calculator. All right, an arithmetic sequence and series. So a sequence is a list of numbers typically that follows a certain pattern. For example, 1, 1, 2, 3, 5, 8, 13. What is that? What is that famous sequence called? Fibonacci sequence, yes. Starts with 1, 1, and then you are just adding the previous two numbers together to get the following sequence and so forth. That is a Fibonacci sequence. Nice try, Araceli. All right, an arithmetic sequence means that the difference between two consecutive terms is constant. This is known as the common difference. So for example, we have the sequence 1, 5, 9, 13, 17, 21. Now in this sequence, the common difference between two consecutive numbers is what? Plus 4. Yes, we are adding 4 every single time. 1 plus 4 is 5, 5 plus 4 is 9, 9 plus 4 is 13, and so forth. Terms in between two non-consecutive terms are known as the arithmetic means. A series is a calculation done by adding all the terms in a sequence. So, depending on how long the sequence is, you would just add all the numbers up together. That is the sum of the series. Just basic vocab. All right, so we have a formula to calculate the arithmetic sequence. So make sure you write this down. It is a sub n equals a sub 1 plus the quantity n minus 1 times your common difference. Just as you see it on the screen, your a sub 1 is the first term in your sequence. The variable d is the common difference. The variable n is the location of the sequence you are trying to find. So we can find like the 10th term, the 100th term, the 1000th term, or whatever. That is the nth term. So whenever you hear me say nth term, that's what I'm referring to. And then, sorry, I was kind of speaking ahead. A sub n, that's when you find your nth term. A sub n represents the 10th, the 100th, the 1000th. N itself in this equation represents how many terms you have when involving a series, like a sum. Or if you're trying to find a specific term, that's what n is. Sorry, it's a little bit confusing when I explain that. N could be the location or n could be the number of terms, depending on the equation. Kind of like an input variable, yeah. All right, so first example, we want to write equations of the following sequences. So go ahead and write these two down. Oh, so one thing that you guys can do, let me go back to the previous page. You should have a full screen button at the top. It says full screen. And it should be next to the cogwheel. If you click that, it'll make everything bigger. That might help. Expands what you're looking at, the chat, participants list. Make sure you hit that button. It'll make things readable a word? Readable? You can also hit F11 on your keyboard. That does the exact same thing that button does. So F11 does the exact same thing if you're using Chrome in Firefox, I think. All right. The problem with using that F11 key or the full screen key is when I have these boxes covering stuff, if you change between full screen and non full screen, it messes that placement up. So it allows you to kind of see what's underneath them. So try to avoid doing that. I think legible is for handwriting, but maybe it applies to typing too. I don't know. You guys should ask your English teacher and get back to me. My English not so good. Okay, first example. We have the sequence -16, -9, -2, and 5, dot, dot, dot. What is our first term? Let me get my pen out. -16. -16. Yep. What is the common difference? Some say 5, some say 7. So mathematically, how do we find that? We have crickets in chat. Use my fingers. Fingers works. Subtract. There we go. 16 minus -9. Perfect. Exactly what I wanted to see. Nice job, Savannah. All right. Well, oh, sorry. You have it backwards. Savannah, you are very close, but you have it backwards. Yep. A2 minus A1. Yep. Chloe is right. Yep. Second minus the first. So I'm going to go ahead and write it down. We're going to have -9. Oops. Uh-oh, my pen doesn't want to do a 9. Okay, let me try this again. Why is my pen doing that? Hold on a second. And the erase tool isn't working very good. Oh boy. Okay. So it is -9 minus the previous. Okay, and then -9 minus -16. So these become a positive. So -9 plus 16 is what? 7. Yep. You guys said that long ago. And for even though like today we're doing arithmetic sequences, you always want to check -9 minus -16. Yes, we get 7. -2 minus -9 also equals 7. That's good. 5 minus -2 is also 7. So you want to check maybe the first three to make sure that you get 7 every single time. Now, if you don't get 7 every single time, it tells us it is not an arithmetic sequence. It could be a geometric or something else. Okay, and then let's go ahead and plug this stuff into our formula. So we should have negative 16 as our a sub 1 plus the quantity n minus 1 times your common difference. Now, right here, where I have this parentheses 7, you don't need to put this in parentheses. You do if it's negative, of course, but if it's positive, you don't have to. I think in some examples I do and some I don't. But if it's positive, you don't have to. If it's negative, you do. All right, let's try this next one. What's our first term? 15. What is our common difference? It is negative 4. Yes, and we know it's negative 4 because 11 minus 15. Oh my goodness. I'm going to have to get used to writing in this software because it doesn't work very well. 11 minus 15, that gives us negative 4. Oh my gosh, that 4 looks like someone else's 4. What is going on today? Hey, I didn't say your name, Emily, but thank you for fessing up. Now let's go ahead and write the actual equation or formula. Everyone go ahead and type it in chat of what it is. Sub n equals 15 plus n minus 1 times negative 4. Good, good, good. And for the last one, this is all pretty good by now, right? First term, everyone can see the first term is negative 25. Maybe I'm just writing too fast. Maybe that's what it is. I'll write slower. Negative 25, our common difference. Nope, writing slow doesn't work either. Negative 17 minus negative 25. What does that equal? 8? That means our formula is this. So with these formulas, we are then able to find the nth term, whether it's the 10th term or the 100th term. And we can even check these formulas that we derived, these equations, and we can plug in 1, 2, 3, and 4 to make sure we get those first 4 terms. So that's one way we can check. All right. So for this one, let's find the 52nd term. So a sub 1, I get 29. Our common difference is 8. There's our equation. So I want everyone, I'll give you guys a moment to, I'm going to check a setting in Windows to see if my pen is set up right. I want you guys to calculate your 52nd term for number 4, 5, and 6. Okay, number 4. What is the 52nd term? 79. Let's see if that's right. That sounds right. 379. Good. Number 5. What is the 52nd term? 115. Good. And number 6. We have 294. Good job. All right, day 1 sounds pretty easy. Can you do time? I can't do timers in Neuro. Mm-mm. That's funny, Araceli. Araceli says, soon we'll all be in the fetal position. My boxes aren't covering correctly. Oh, yeah, they are. Never mind. They're working fine. Okay, so we're going to reverse engineer. So we want to find our common difference. We have 18 blank blank 3. I'm sorry, not 18. We have 1.8 blank blank 3.3. So let's do a step at a time here. What is our first term? 1.8. So 1.8. What is the fourth term? 3.3. Yeah. 3.3. So we're going to have to derive. Well, so we know the first term, we know our fourth term, we know the number of terms. We need to find the common difference. So how many terms do we have? 4. So n in this case will be 4. We know it's 4 because we're doing a sub 4. And in the equation, that would be your n. So right here, because of we're using the fourth term, the n is 4. So keep that in mind for this equation, a sub n, so your n is 4. We're going to plug that stuff in. And then we can derive our common difference. So everyone go ahead and do the maths and tell me what you get. Looks like somebody got a half. So remember, since we started with decimals, your final answer can be in decimals. Got 11/16. Got 0.6875. 0.5. Got another 0.6875. Looks like 0.6875 is the popular choice. Let's see what we have. So 4 minus 1 is 3. From this step, what should we do? Subtract 1.8 both sides. Good. Then the last step, divide by 3. Okay, so if you made a mistake, you probably found it. And that's how 0.5. So even though the popular choice of being 0.6875 was not correct. So does everyone agree it's 0.5? Okay. So everyone that got that 0.6875, you found your mistake? Good. Good, good, good. And it's probably an easy mistake, right? Did you guys add 1.8 and 3 together? Yeah, that's bad. Don't do that. Numbers and so those are constants and coefficients. Cannot be added. All right. Next example here. We have the first term being negative 32. Our fifth term being negative 64. All right, plug those in. And of course, our n is 5. All right, let's do the math on this. Not, yep. Negative 60y. Yep, it's a new number. So the common difference is subtracting 8, negative 8. And we can always check that pretty easily. Negative 32 minus 8, minus 8, minus 8, and then minus 8 should be negative 64. And I think that's right. Oops. Oh, see, I had a typo. I forgot my negative when I carried down my 32 there. Negative 62 plus 32 is negative 32. So let me go ahead and fix that. Should be a negative 32 in this step. Dividing by 4 gives us a negative 8. So in your downloaded file, make sure you fix that. And I will do the same. All right, I'll better. Okay, what is our common difference for the last example on this page? Two. Let's see if that's right. Yep, we got 2. Good job. Let's go ahead and just fill in everything else for completeness. This is negative 27. A sub 5 is negative 19. Ugh, this does not like my pen in this program. Okay, any questions on this page before we go on? Pretty straightforward. So, finding the common difference when at first glance it looked like how we do it, but once we do a couple, pretty easy. All right, fun story. Does anybody want to go on mic and read this to us? And by the way, that last name is Gauss. When you pronounce that last name, it's Gauss. All right, Julia, you should. Oh, if you have mic access. Do you have mic access? You should.
Testing, testing. Can you guys hear me? All right. When Carl, what was it again? I just
Gauss.
forgot. Gauss. When Carl Gauss, a famous mathematician, was in elementary school, the students were annoying the teacher so bad that she gave them the task of adding up the first 100 numbers to shut them up for a while so that she could get some things done. Though it should have taken the students a good long while to finish such a task, the teacher was shocked when Gauss approached her with an answer in just a few minutes, which was later determined to be correct. How did he do it so fast?
Ooh, how indeed. All right, Julia, continue reading, please.
Essentially, their task was to calculate 1 plus 2 plus 3 plus 5 plus blah 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 plus 99 plus 100. While doing this directly would take a while, Gauss noticed something right away. Add the first and last term together.
All right,
Add the
everyone. Oh, you can stop it there. Thank you.
second to last term together. Add the third and third to last term together. What pattern do you see?
All right. So, what is the first and last term added together equal? 101. Yeah, 101. All right. What does the second and second to last term added together equal? Weird. Another 101. All right. And then what is the third and third to last numbers added together equal? Weird. Another 101. This is interesting. So, what pattern do you see? 101. Yeah. As we keep going in, keep adding these two numbers, 101, keep going in and in and in, down to the middle, it's always going to equal 101 in this example. So that leads us to the formula. To find the summation of this arithmetic sequence, it is denoted as S sub n equals n divided by 2 times the quantity a sub 1 plus a sub n. And right below here, I do have, so this is the formula, and we could rewrite this formula with our a sub n. So we learned the a sub n formula on the previous pages. We can substitute this variable for that equation. And that's why I have it written in blue here. So a sub n is equal to a sub 1 plus the quantity n minus 1 times your common difference. That's why I have that here. And then I simplified it. So we have a sub 1 plus a sub 1 is 2 a sub 1s, right? We have 2 times of them, plus the other stuff. So your formula to find the summation of your arithmetic sequence could be done with this equation here or this equation here. It does not matter. If you're given your first and your last term, use this one because it's less, right? There's less math. If you don't know what your last term is right off the bat, but you're given your first term, you're given the number of terms, and you're given the common difference, you would use this equation. It is not an infinite. So hold that thought. Yes, we will do infinite arithmetic series. I don't think we do it today, though. There's a special condition of when we can do infinite summations of arithmetic sequences. There's a special condition. We'll get there. Okay, so number 10. Given this sequence here, 18, 24, 30, 36, ... The number of terms is 11. We are not given the last term. Now, if we wanted to, we could use the a sub n formula, and we could find that 11th term and then use this first formula here and do it that way. Or we can just make it easy on ourselves and just do it all at once and use this formula. Because we're given the number of terms, we're given the first term, and we're given the common difference. Well, kind of. We have to calculate that. What is the common difference in this sequence? 6. Yeah, because 24 minus 18 is 6. 30 minus 24 is 6. 36 minus 30 is 6. So we did plenty of checks. It's 6 every single time. So that means the common difference is 6. So what goes right here underneath this first blue box? 11. What goes underneath the next blue box? 18. Because it's our first term. What goes under the next one? 11 again. And the last blue box on this line, common difference, 6. We calculated that to be 6. Okay, everyone do the maths and tell me what the summation is. So I've got 528 from 2 people. More people say 528. So maybe it's right. So remember, the majority has been wrong before. 528. Let's see if that's right. Yeah, it is 528. Let's see what I did here. Looks like 11 over 2 just stays 11 over 2. I'm just simplifying stuff here. 2 times 18 is 36. 11 minus 1 is 10, and then 10 times 6 is 60. And then you can just do 36 plus 60, and then times that by 11 over 2, or just type it in from here. It doesn't really matter. I think maybe doing this work from here to here and then typing this part in is easier to type in than typing all of this in. The more parentheses that you have when typing stuff in, the the bigger chance you're going to have of making a mistake. But yeah, I would probably do this stuff by hand and then type this in. I don't hate all calculators. I like this one. Got this Casio FX. I think that's a very good model. The Casio FX 115 ES I think is an excellent choice. I also have. I don't use it. Oh, there it is. I have a TI-89 titanium. I do not recommend this model because it is complicated to learn and use. I would say for most people, it's complicated to use. I reckon if you're looking for a graphing one, I would say get the TI-84 Plus, whether it's the color or the non-color version, or the TI Inspire. And it's expensive, yes. Okay, let's go to this last one on this page. This is, oh, I have just these two more examples. All right. Go ahead and talk about this stuff. So in this sequence, what is our common difference? 7. 20 minus 13 is 7. 27 minus 20 is 7. 34 minus 27 is 7. So good. You can go ahead and put 7 right here. What does n equal in this example? N is 20. That's given. So I can just put 20 wherever I see n. And then what is our first term? 13. All right, everyone do the maths and tell me what your summation is. 1590. That's right. I think it's right. 2 times 13 is 26. Oh yeah, 20 divided by 2 is 10. And then 20 minus 1 is 19. 19 times 7 gives us 133. And then we just do the math from there, and that's how we get 1590. Not too bad, not too bad. All right, last example of the day. We're actually ending on time, it looks like. Ooh, 10:49. I am ending on time. How about that? That might be the first and last time I do that this term. Just kidding. Kinda. Uh, you can't spell. I can't speak. Everything gets harder from here. Yeah, probably. It's probably a good guess. I'll give you another minute. You know what I should do is install OBS and create some on-screen timer effects since we don't actually have them in New Row. If I have time, maybe I'll do that. So some 390s. Some more 390s. Let's see. 90. 390. Nice job. Common difference, everyone found to be 4. N is 13, and a sub 1 is 6. Some basic math here. We get 12 there, and we get 48 here. Type the rest of the stuff in. That's how we get 390. So some final thoughts. We were given basically 3 equations, right? 3 equations. First equation was to find the nth term. We also use that same formula to find the common difference when you were given, let's say, a gap, right? You're given your first term and then maybe the very last term, but nothing in between. We were also given the summation equation, and we use that to find the summation of the arithmetic sequence. And we're given 2 forms of that. One of them, which we use for these examples, was used when you had your first term, the common difference, and the number of terms. The second case, we actually didn't use today, but you may use on your quiz and or on your test. And that's when you're given your first term, your last term, your first and last term of the arithmetic sequence. Other than that, guys, well, I hope you learned something, and I will see you tomorrow for day 2